Sargun, we are studying about center of mass, okay, today. Okay. Perfect. Okay. So now I want you to experiment a few things. Sargun, I can't see your scale, huh? I want you to put the scale like this first. This way. ऐसा रखना है. कुछ हो रहा है? Are you able, is it stable? गिर जा रहा है ना? गिर जा रहा है? Let's bring it little in the center. Now in the center. वहाँ पे रखो. क्या होगा? Is it still falling? Put two fingers in case you're not able to. So I can see Sargun का balance हो गया. Even Gauri का भी almost balanced, right? Gauri's is almost balanced. अब अगर मैं आपको बोलूं कि अपने अपने fingers को थोड़ा right की तरफ shift कर दो, will it still be balanced? Try doing it. Will it still be balanced? Q, because क्यों गिर गया Gauri? Because first of all, we are
shifted from the center of mass.
Yes, we have shifted the base, the pivot point from the center of mass. हमने center point जो है वो हटा दिया. हम center of mass पे नहीं अपना finger रख रहे हैं, right? And what is center of mass? That this side and this side both are balanced, right? अगर वो balance नहीं होएगा तो हमारा कोई भी चीज. Now I had this habit when I was a kid. So I used to eat on my dining table. और मेरे को चेयर को हिलाने की आदत थी, you know, that it's so much fun, you know, when you just try to make your chair थोड़ा सा, you know, you push it back, and then one day I pushed, फिर I thought I'm a pro in this and I will never fall. All right, so मैंने थोड़ा और ज़्यादा I was pushing myself, and one day along with my food, everybody, you know, everything fell on me. Why? Because my chair tilted completely. Now, why that happened? Because I am sure you must be doing it also. Mainly USA, right? I'm sure you must be enjoying that, you know, tilting the chair while you're just sitting and relaxing and chatting, right? Yeah. So what happens? Again, when you're doing that, जब तक आपका center of mass is there, you're stable. But the moment it's not, you know, you're not able to maintain the center of mass, it falls. Okay. Now we have a few things. एक experiment है जो बहुत important है. Do you see this experiment here? Right? Now this is, this was like your scale. This was like your scale, right? So scale को balance करना आपको आ गया. What if I have an object which is little irregular in shape? I can't see that it's not a particular square or a एकदम perfect shape नहीं है. Some irregular shape, and I want to figure out where is the center of mass. Okay, so how do I figure it out? So do you know about this experiment to find the center of mass?
Yeah.
What is
We've done it practically in school, I think.
Practically. So can you tell me a little bit about the thing? Who can tell me? Sargun, you remember?
So
yeah, so basically there was a card we had, and then it was like stuck to a board with a pin, and we had held it like up, but when we left it, it swung down and was like hanging from there.
Okay, so you've explained it till here. Okay, now Gauri, I want you to explain this one. यहाँ क्या हो रहा है, Gauri?
So the part about the plumb line, so what happens is when we left the object like that and just put the plumb line on it, what basically happens is that the center of mass is always going to be in a straight line.
Okay.
It was just like this straight kind of line, kind of string.
So what exactly is that plumb line? How do you make a plumb line? How do we make a plumb line? Do you see there's something hanging here? And there is
there's one object that kind of hangs there to just keep the weight.
So you take a thread.
Otherwise it would just go here and there.
Otherwise the thread will just flow here and there, and you won't be able to make a line. So what you do, you hang a thread, and in that thread you hang what? You hang a weight, so that first of all the thread is all stretched out, becomes like a line, and because it's a thread, so it might just waver here and there, and you will not get a proper line. So you hang a weight to it, and then what you get here, then what you make is a plumb
Straight
line.
line. Yeah.
Straight line.
Vertical plumb
Vertical line. Okay, so
which
you
helps
understand
in finding the center of mass.
Absolutely. So बस एक line बनाने से हो जाएगा हमारा काम. Do I need to make it?
No.
Then how many lines do I need? A
One
minimum
more.
of
You make at least like 2 or more.
at least 2.
And you find out where the lines are intersecting.
That, and the intersection
Center of
point
mass.
becomes your
Center of mass.
Absolutely.
Center of
Excellent,
mass.
girls. Very good. Very good. Okay. Now let's talk a little bit about stability. And this is what happened with me. So, क्या देखते हैं? So what exactly happened in the chair? This is absolutely एकदम एक chair जो है वो बिल्कुल आराम से बैठा हुआ है अपने चारों पैर पे, right? All the 4 legs, it is stable, completely stable. So weight is this, and ground से जो उसका opposite weight आ रहा है, that is this one. So you can see this, right? Weight is downwards and the force upwards is, so everything is stable, कोई problem नहीं है. फिर पूजा आंटी ने कर दिया थोड़ा सा अपना chair tilt. तो क्या हुआ? Where is the center of mass? Here, but now this leg is up and everything is on this leg, right? तो अभी क्या हुआ? हमारा center of mass क्या हो रहा है?
Yeah.
अभी center of mass क्या है? अभी center of mass still it is here. इसके left पे है ना? But अभी क्या हुआ
Right.
यहाँ पे? अभी क्या हो गया? इधर क्या हो गया? मैंने थोड़ा ज्यादा ही खुशी में ना बहुत मजा आ रहा था मुझे करते करते, तो थोड़ा ज्यादा ही टिल्ट कर दिया अपने चेयर को. So now what happened? ये इधर आ गया and this is now center of mass is there
On the right.
to the right. Okay.
Yeah.
With the last till the forces will tip the box over. Now क्या हो गया? Center of mass पीछे की साइड चला गया and now there is no stability anymore. So the more I'm doing this, the more it is going, तो मेरे गिरने की tendency और बढ़ती जा रही है, right? So till this is maintained, I'm still okay. But जैसे ये center of mass से इधर हुआ, this thing. So what is happening now? I will fall down. Clear? Understood? Absolutely clear. So this ये वाले केस में तो बिल्कुल ही मतलब इसमें तो center of mass काफी पीछे चला गया. So the chair has to fall down. Okay. Now we have some particular figures. You understood why I fell down that day, right? Now there are certain figures जिनका center of mass हमारे को perfectly पता है. One we saw the scale. What about this? This is what shape is this, Sargun?
A cone.
A cone. So if you tip the cone a little, the center of mass stays over the base, so the cone falls to the original position. Little bit अगर आप tilt करोगे तो क्या होगा? It is यहाँ पर center of mass है. What point is this? Center of mass का ये point क्या होता है ये इसमें in a cone?
Center of mass in a cone.
Yeah, center of
I
mass in a
don't think we've learned. I don't think we've learned about in a cone.
Okay. So you know what is a median? Median पता है ना हमें?
Oh, right. We had learned about that while we were doing center of mass of a triangle. We had learned.
So cone is a sort of a 3D of a triangle only, right? So you got it now. What it is? What exactly the center of mass would be? The intersection point of the medians.
Okay.
Just in a 3D way, but it's in the 3D form. And where is it? It's 2 by 3. This point, the point where all the medians meet is 2 by 3 of the whole median. Clear?
Okay.
2/3. That's this point. If you see, ये gap कम है. ये gap ज़्यादा. Do you see that?
Yeah.
This is 2 by 3. Understood? Clear?
And that part is 1 by 3.
Now,
Got it. Clear.
Right. अभी मैंने अगर कोन को इस तरीके से रखा तो ये स्टेबल है, बट अगर कोन को ऐसे रखा तो ये अनस्टेबल हो जाता है या नहीं हो जाता?
हो जाता है.
Why is it unstable now? ये वाला, why is this unstable and this is stable? Sargun, why do you think this is unstable?
Because there isn't like the base, it isn't that big, it's very small. So the center of mass, it like doesn't stay in a stable
Very
position.
difficult to maintain this center of mass right in the center. बहुत जल्दी वो tilt करेगा, right? Tilting happens more in this case, whereas in this case it is not, because base बड़ा है. Base बड़ा है तो कोई problem नहीं है. लेकिन जैसे हमने ये किया, but there are some people ना who are able to do this, maintain, है ना, कर लेते हैं ना, because they are very good. You have seen those people who are very good with rocks and they put one rock over the another and then another one and then it stabilize all of those rocks.
Hmm.
Seen that how they do it? It's all a game of center of mass.
They're probably aligning the centers of mass.
Yeah, that's very good with aligning the center of masses. And I saw one lady, I don't know what it was, in some talent show. She was putting feathers and feather and end of one feather and another end of one feather. It was beautiful the way she was putting it up. It was again a full game of center of mass. How she was stabilizing a feather. I'll send a video if I get it. I'll definitely share it with you. It's a wonderful video. So these are what these people do. They always maintain the center of mass. Okay, it's a very creative thing, by the way. We are learning this in physics, but it's a very creative. People make a lot of things out of the center of mass. Now coming to, what about this one, Gauri? Is this ever going to be unstable?
No.
You?
I don't think so. It's a sphere, right? If you move it, it's going to just keep rolling around. It's not going to tip over as such because there's nothing to tip over.
Correct, because the center of mass is never, so the center of mass and the weight is always aligned. That is why. Right. Here center of mass and weight are completely aligned. Here they're not aligned because it tips over and they become this. There's a disalignment between them. Here the alignment is much better.
The sphere always stays like that.
Right, absolutely. Understood. So we have understood this center of mass thing, right? Absolutely clear. Thoda revise ho gaya, right? Sargun, so if your mama wants to test you, tell her that she can test you now on center of mass. Okay. Yeah. Okay. All right. So on figure 2.1, draw and label an arrow to show the weight of the slab acting at its center of mass. Calculate the moment of 40 newtons force about point D. अब ये moment पे भी आएंगे. अब इसका center of mass किधर होगा? This is the figure that you have. कहाँ पे बनाऊं? इसका center of mass किधर होगा? It asks us to show the arrow, weight arrow, right? Mass of a weight का arrow बनाना है. कहाँ बनाऊं? Where do I make it?
Yeah. Oh, so you make a diagonal.
I make a diagonal, okay?
Like the diagonals and where the diagonals intersect. Yeah.
Okay. So in a square, Sargun, and in a rectangle, it's where the diagonals meet, correct?
Yeah.
Where the point where the diagonals meet, this point, that becomes your center of mass. That's where the weight is. The weight is, I would not say the weight is concentrated there. I would say the weight averages out there. Average idhar ban jata sara. So ek taraf aur dusri taraf
averages out. Okay.
Averages out there. Okay. Calculate the moment of 40 Newton force about point D. अब मुझे quickly Sargun आप मुझे ये बताओ कि moment का formula याद है? How do we calculate moment? Moment of force. Moment of force कैसे निकालते थे? Remember? याद नहीं है?
No,
that's okay. अभी वापस पूछूंगी तो याद रहना चाहिए. Okay, Gauri, do you remember what is the formula? Moment of force.
It's the force multiplied by the perpendicular distance.
Okay, so quickly, force multiplied by perpendicular distance, right? That is what? Moment of, please note this down. Moment of force. Okay. Moment of force में ये क्या है? Force. अभी force multiplied by perpendicular distance from where, beta? From where is this perpendicular distance?
From the pivot.
From the pivot. That perpendicular distance has to be from the pivot. So suppose I have a slab like this, and I have this point where the pivot, this point where the pivot is, and I want to calculate the moment of force here at point A, then how do I calculate?
With your force here. So you will take the distance between that pivot and A.
Yeah. This is your pivot. So यहाँ से यहाँ तक का जो distance होगा, that is the perpendicular distance. Okay. Okay, Sargun, this is the perpendicular distance. And what is the force? The force, the weight here. Either जो भी force होगा, that is the perpendicular. That is the force. So that force multiplied by the perpendicular distance gives you the. So let's come back to the question. Tell me, it says moment of the 40 Newton force about point D. About point D.
Yeah.
Hmm.
14 Newton force about point D. So in this case, point D is going to be acting as the pivot.
Yes, this is your pivot. जहाँ पे point D बोला, okay, this is D. So this is your pivot.
Yeah.
About point जहाँ बोला सरगुन, about जिस point के लिए बोला, that is your pivot. And the 40 Newton force is being applied like this, right? Okay.
Yeah.
Then, so what is the perpendicular distance? Is the distance from the force to the pivot? From
Yep.
the force to
Yeah.
the pivot? Force from the force मतलब जहाँ पर 40 Newton लग रहा है, and to this pivot. Pivot यहाँ पर है. तो कितना distance है ये? How much?
0.6 meters.
0.60 meters. So how do I calculate now? What is the answer for this? I will write moment
14 multiplied by 0.6.
force multiplied by perpendicular distance, which is 40 multiplied by 0.6. So इसका unit बता दो सरगुन मुझे.
It will be
force का unit
newtons,
and perpendicular distance का unit.
meters.
So what is the answer?
Newtons per meters.
Not per meter, Newton meter.
Just Newton meter because it's
Multiplied है ना? Per होता जब division होता. Okay. So अब Gauri, give me the answer. What is the answer that you got?
24.
24. Yeah.
The moment of W about point D. Moment of W.
I think
W is the-
I think they mean like the weight.
Hmm.
Yeah, the weight, the center mass, that way.
Okay. So just figure it out. Just give me one moment. There is one thing that. Just give me one. Sorry. Yes. Yeah. So about the W is here. W is this, right? Okay. Ab batao, how do you figure this out now? If this is W. What is W, Sargun?
The weight.
The weight. अब हमको क्या निकालना है? How do we figure this out? How do we figure this out, Gauri?
So what's basically happening is that the weight is acting this way. So we'll be finding the horizontal distance, which will be, since the center of mass is going to be directly above like the middle point of that line, it's going to be 0.15 meters away. And then we just multiply whatever the force is with 0.15.
And how do you know it is 0.15?
Because we have the measurement of the entire side, 0.8, and the diagonal is going to be right above that midpoint of that. So,
Midpoint. Okay. So Gauri, Sargun, did you understand this part? ये कैसा हुआ? ये रहा हमारा. This is like how the weight is, right? यहाँ पर this is how the bar is, okay? And I will wait. I'll just draw it properly. This is how your bar this. Okay. Here is your point D. This is point D, which is what? The point D is what? That's your pivot. Okay.
The pivot. The pivot,
Huh?
yeah.
Pivot.
Yeah.
Where is the weight? Weight is right here. How much is the weight? Weight we had calculated 180 newtons. Right? 180 newtons. Now this weight is where, if you draw this line, it is where, at what point? In the right in the middle. So what is the distance between this? Agar ye pura distance is given to us as 0.30, how much will be half of this?
0.15.
0.15. So you have 180 newtons multiplied by 0.15. Did you get it?
Yeah.
Force multiplied by perpendicular distance. Clear? So that is your moment of force, right? Write it down, okay? Draw this. Force multiplied by, so kitna hua answer? What's the answer?
27
27 what?
27
Newton
meters.
meters.
All right. Now, the ground is rough, so the slab does not slide. State and explain what happens to the slab as the horizontal force at B is gradually increased. Horizontal force at B. Horizontal force at B is gradually increased. What is horizontal force? You're pushing it,
So
right?
that horizontal force.
Hmm.
This way. Yeah.
So what will happen? What will happen? वही जो मेरे
If
चेयर
you-
के साथ हुआ
हाँ.
तो क्या होगा? How will you explain? What are you doing? You're increasing the force, right? 40 Newton से बढ़ाते जा रहे हो, which means pushing is more, right? So what will happen? जब तक
The center of mass is like above the base, it will, remain stable. But the moment it passes beyond, like to the left or right or anything, it will lose its stability. It will fall.
Yes, and till what time it won't fall? Till the time the center of mass is behind, and जो weight है वो weight and center of mass, that is, center of mass can change, weight can't change, right? Center of mass changes and weight of the chair will not change, right? जब तक वो दोनों stable है तब तक ठीक है. जब वो दोनों अलग-अलग alignment में नहीं है, that's when tilting, that is what happens when tilting, when you're tilting the thing. So जब दोनों aligned है, what are the two things which are not aligned? Center of mass and weight. Weight is something which will remain, but center of mass changes because you're tilting the thing, right? Center of mass change. और वो जब तक alignment में है तब तक तो ठीक था, but कब तक भी वो गिरेगा नहीं, वो आ जाओ आपको जो मैंने एक फिगर दिखाया था, वो कब तक नहीं गिर रहा है? स्मॉल टिल्ट है तब तक नहीं गिर रहा जब तक कि सेंटर ऑफ मास आगे है और दिस इज बिहाइंड. बट द मोमेंट ये सिचुएशन आ गई, ये वाली सिचुएशन आ गई कि दैट द सेंटर ऑफ मास हैज मूव्ड अहेड, the weight has moved ahead and this is not an alignment. That's when, यहाँ तक ठीक है, you're understanding, because यहाँ पर अभी क्या है, the center of mass is here and the entire weight has shifted here. लेकिन अभी क्या हुआ, ये आगे हो चुका है और ये पीछे जा चुका है. Are you getting it? That's when it's a larger tilt, and that's when it will fall down. So what do we write here? How do we write it here? Got the point?
Got the point.
Yeah.
Got the point? So how do we write it? I want to.
Yeah. Let's do this.
If the tilt is
So
small,
as the horizontal.
if the tilt is small, then what will happen?
It won't tip over.
It won't
Then
tip.
you go back to its original position.
Yeah.
It won't tip over.
It won't topple. But if the tilt is more, it will topple because the center of mass and the weight are not aligned. Clear?
Yeah.
Okay.
Yeah.
Then we come to the next question. All right. So Now this question, Sargun, you can tell me the first answer. 4A. How do you do this one? Read the question, Sargun.
A large crane has a mass of 8,500 kg. Figure 4.1 shows the crane on a muddy building site. Calculate the weight of the crane.
Weight is?
Sorry?
How do we calculate the weight?
Is it, I'm not sure, but is it mass into gravity?
It's not gravity, it's acceleration due to gravity. So weight is equal to, very good. Be confident when you're answering. M into G. How much is M?
8,500.
8,500. And what is G?
10.
10. So what's the answer?
It's 85,000.
And unit?
It will be newtons.
Newtons, because it is force. Force and a weight to. Okay. All right. Gauri, next one. Sargun, ये देखना आप क्योंकि गौरी के साथ अभी मैंने ऐसा एक क्वेश्चन किया है. All right. So you have to be very careful in how we are doing this. Next question, Gauri, read it.
Okay. The crane rests on two caterpillar tracks, which has contact area with the ground of 3.4 meters square. So one caterpillar track has 3.4 meters square, the other one also has 3.54 meters square. Then calculate the pressure that the crane exerts on the ground. So we already have the force, which is like the weight, which was already calculated. And we'll get the area by doubling 3.4 because it's for two caterpillar tracks. Then we just divide the force by the area.
Okay, so first of all, pressure is equal to force upon area, correct?
Force upon area.
And
yeah.
Force is how much? Force you just calculated, Sargun. It is force is nothing but the weight, so it is 85,000, right? Now area is, what is a caterpillar track? Caterpillar track हम किसको बोलते हैं? What is a caterpillar track? This यहाँ पर जिसमें वो रेस्ट कर रहा है. So ऐसा कितना tracks है हमारे पास? Right? ऐसे कितने tracks हैं? 2. On this side, other on that side, right? 2. So area will have to be multiplied by 2. अगर एक का area 3.4 है तो दो का area
6.8.
6.8. So 3.4 into 2. Got it? What's the answer? And unit बताना मुझे. Very important.
It's 50,000.
12,500.
Okay, right. You're right.
What's the answer?
12,500 pascals.
12,500 pascals. Take care. Clear? Sargun, there's another unit for this. What is it? If not pascal.
It's newtons per meters.
Per meter होगा. Newton per area है ना? Area का unit क्या होता है?
Meter square. Okay.
तो न्यूटन्स. अब यहाँ पे पर है क्योंकि यहाँ डिवीजन है. मोमेंट में पर नहीं था, न्यूटन मीटर था वो, क्योंकि वहां पर मल्टीप्लिकेशन था. क्लियर? सो इट्स न्यूटन्स पर मीटर स्क्वायर और पास्कल्स लिख सकते हैं. ओके, नेक्स्ट. Sargun, read this question.
As the crane driver walks towards the crane, he starts to sink into the mud. He lays a wide plank of wood on the mud as he walks along the plank. Explain why he does not sink into the mud when he walks along the plank.
I have a story again. So I went for a party once, all dressed up in my heels, and I was wearing, you know what is a stiletto? Yeah, so I was wearing a stiletto.
Yes.
All dressed up in a very nice, it was a Diwali party. So I came out of the car. So आराम से बाहर निकले, heels पहने हुए, बहुत अच्छे से walk करते हुए. So the moment I stepped out of the car, it was a road. So road is rigid, right? So you are able to walk very nicely. And then suddenly I get into the place where the party is. And जैसे मैंने enter किया, It was so high, everybody, high, high, high. And suddenly I was like, oh my God, what happened to me? So what happened? The moment I stepped into that garden, now my heels, imagine मैं ऐसे अच्छे से walk कर रही हूँ, and then I get into the garden and that heel जो है, that is into the mud. Okay. And I was like very, very nicely walking pura, and suddenly I find myself, almost 2 inches into the mud, because, and that to where the heel side of it. So embarrassing. So suddenly मैंने वापस अपना heels को बाहर निकाला किसी तरह से, and then I stepped again. I put my other foot ahead, and that also goes down. Imagine that walk from the from the gate till that place. I find a chair for myself. That walk was the most difficult walk of my life, because every time I was putting my next foot forward, I was just, my heel was going into the ground, and I had to really pull myself up and put the next step. And then I realized, oh my God, all of these females, none of them are wearing their shoes, because they all removed it because almost everybody was in the heels. Kisne nahi nikala? Those who were wearing platform heels, they were better. And the men who were there, so they were all very comfortable. Except them, everybody else had removed the shoes. Kyun hua ye mere saath aisa? I have many stories. My God, such embarrassing stories. कभी मैं गिर जाती हूँ, कभी मैं जमीन में चली जाती हूँ. अब ये क्यों हुआ मेरे साथ?
Because all of the force was concentrated in that really small area. The stiletto heels are like very, very tiny.
Right.
So you sank into the mud.
I was really into the mud. So pressure is equal to force upon area. For me, the force was my weight, which I'm trying to lose upon the area. और ये lose नहीं होता है, right? और हुआ क्या? The area of my heel was this thin. So the area was too small. अब क्या होगा? The only way that I reduce the pressure is if I increase the area, right? So weight तो change नहीं होगा अब सुबह से शाम में, तो अब area को ऐसे ही play करना पड़ेगा. So I have to reduce the area. So अब area reduce करने, I have to increase the area to reduce the pressure. अब क्या हुआ? Stiletto में, like you said, the area is too small, बहुत छोटा सा area होता है. But for those men, what happened? ये पूरा जो पूरा foot है ना उनका, that area was supporting their entire weight. So they were not sinking into the mud, whereas I was. Okay. So, but when I removed my shoe, then I was comfortable. Kyun? Because I increased the area. Correct? Right? So, you understood the concept here? कि ये मेरे साथ ऐसा क्यों हुआ?
Yeah.
Right? All right. Very nice. जो लोग platform heel पहने हुए थे उनके साथ क्यों नहीं हुआ?
They had more area.
Because they had more area. So अगर pressure reduce करना है तो दो काम करना है, या तो अपना weight कम कर लो, जो होगा नहीं इतनी जल्दी, right? या फिर अपने heels change कर दो, right? Or where you're at a party. If it is a garden party, definitely do not wear a stiletto. Okay, chalo. Now next question. Part 2. Chalo. Whose turn is it to read now? To answer this? I think Gauri, right?
Yeah, I guess so. So when the crane lifts a heavy load with its hook, the load exerts a moment on the lifting arm about the axle. Explain what is my moment of force. Okay.
Okay, I think we were supposed to explain this one. जिसके लिए इसका answer क्या लिखना है? Just tell me the answer for this once. Then we will come to the C part.
So,
ये वाले.
Why he does not sink into the mud
Because
when he walks along the plank?
More area than
large area. Large area. Hence, what happened? Pressure पे क्या effect आया? Hence,
the pressure decreased.
Smaller pressure. Small pressure. Right. Very nice. Chalo. Yes, Gauri, now you explain this. Explain what is meant by moment of force.
Of force. Okay. So moment of force is the value for in the perpendicular distance, right?
Hmm.
So it's about, I think, the force when it's involving a pivot. I'm not sure exactly how you would frame it.
Okay, okay, let's. What you're saying is absolutely correct. इसको बस एक wordings दे देने हैं आपको, ठीक है? So again, I am in a park, and this is the pivot. वो ये क्या है? What is it? What am I drawing? Another child.
You're drawing a seesaw.
Seesaw. Okay, so we are playing now. Okay, in the park. तो ये कैसे खेलते हैं? ये how does a seesaw work?
It goes up and down
It
as
goes
the
up and down. So किसकी वजह से up and down जाता है?
weight.
The weight. तो इसका weight 1, इसका weight 2. जिसका weight ज्यादा होगा वो क्या करेगा?
It will go down.
It will go down. All right. लेकिन अब दो बच्चे बैठे हैं. एक one has a weight of almost 80 kgs. Another has a weight of 40 kgs. ये 40 kgs को smartly act करना है. क्या करना चाहिए इसको? And you all do it already, हाँ? आप लोग करते हो ये पार्क में, बट पता नहीं चलता कि हम लोग इतना बड़ा कॉन्सेप्ट कर रहे हैं वहाँ पे. क्या करते हैं हम यहाँ पे? क्या करना चाहिए इसको? 40 वाले को? Is the moment of force just dependent on the weight, or there's something else there?
The force.
The
Moment
distance.
The distance. So moment of force इसको हम टॉर्क भी बोलते हैं, ठीक है? मोमेंट ऑफ फोर्स को हम टॉर्क भी बोलते हैं.
Torque with, yeah.
Right? So that is force यानी कि weight multiplied by perpendicular distance. अब इसने देख लिया यार मैं तो 80 kg वाले के साथ हूँ, तो weight से तो मैं कुछ नहीं कर सकता. I will always be up. और वो जो है ना weight वाला, जो ज्यादा weight वाला है, वो उसको सुन ही नहीं रहा, वो उसको बोल ही ना, वो उसके ऊपर हंस रहा है. नहीं नहीं नहीं, I will not. So what should this child do? This little one, what should this one should do? So what is the other thing that it is going to play with? It is the perpendicular distance. क्या करे ताकि उसका perpendicular distance ज्यादा हो जाए? क्या करे? क्या करे? तो अगर ये इसके पास पीछे स्पेस है, तो वो जितना पीछे मूव करेगा उतना उसका मोमेंट ऑफ फोर्स ज्यादा जाएगा. सपोज मैंने देखा कि इसके पीछे स्पेस है, तो इसको बोला जाएगा जाओ तुम पीछे मूव करो. अगर तुम पीछे मूव करोगे तो क्या बढ़ जाएगा? यहां से यहां तक का डिस्टेंस बढ़ जाएगा. सो द मोर इट इज, द मोर विल बी द मोमेंट ऑफ फोर्स. करेक्ट? राइट? या फिर अगर उसके पास स्पेस नहीं है तो वो क्या करेगा? बहुत स्मार्टली इसको बोलेगा तो थोड़ा आगे हो जा, जरा थोड़ा आगे आके बैठ. और वो जैसे ही आके बैठेगा, इसका डिस्टेंस कम हो जाएगा, तो इसको दिस वन विल गेट एन एडवांटेज. आर यू गेटिंग इट? आर यू गेटिंग दिस?
Yeah.
राइट? सो सीसॉ करते हुए दो बातें हैं. क्या है? क्या है? एक तो ऑब्वियसली योर
One is the force and one is the perpendicular distance.
Okay. Now हमने इसके साथ तो समझ लिया. What if there was no ground? अगर ये ग्राउंड होता ही नहीं, तो ये क्या ऐसे करके घूमना स्टार्ट हो जाता? Would this keep on rotating like this? Like a what is that big wheel? किसको बोलते हैं?
Ferris wheel.
हाँ?
Ferris wheel.
Ferris, whatever. जो that big wheel on which we sit and we fairs में जो होता है. Got it right? The big wheel.
हाँ.
हाँ? So that wheel, उसमें isn't it also similar? But उसमें क्या होता है? वो turning effect के वो moment of force actually क्या create कर रहा है? It is making it go round and round and round, right? Right? And that is
Right.
moment of force. That is the turning effect. Moment of force is also the
Turning effect of a force.
Got it? Also called as torque.
Torque.
Right? जो सिर्फ फोर्स पे डिपेंडेंट नहीं होगा, ये इस पे डिपेंडेंट होगा कि आप उस पे बैठे हो और कितने दूर बैठे हो. दोनों चीजों पे डिपेंड करेगा. राइट? ऑल्सो वन मोर इम्पॉर्टेंट थिंग, यहाँ पर फोर्स कौन से डायरेक्शन में लग रहा है, दैट इज ऑल्सो वेरी इंपॉर्टेंट. इधर से है कि इधर से है? अगर ऊपर से आया तो ये इसको कैसे मूव करेगा? अगर फोर्स यहाँ से सपोज, तो ये ऐसे मूव करेगा, विच इज विच डायरेक्शन? एंटी क्लॉकवाइज. लेकिन अगर ऐसे आया तो ये इसको ऐसे मूव करेगा, विच इज क्लॉकवाइज. दिस इज एंटी क्लॉकवाइज एंड दिस इज क्लॉकवाइज. एम आई राइट? right?
I'm just going to change my network.
I think you're lagging today, Gauri,
Yeah.
quite a lot, right?
Am I audible now properly?
You're audible, but just that you're lagging
The video.
the video a lot.
Okay.
सरगुन ये बात क्लियर हुई हमको? आज
Yeah, I'm clear.
fully concentrated on center of mass and we are doing this moment of force, right? अभी आते हैं. Despite the moment exerted on the lifting arm, the crane remains in equilibrium. State the two conditions required for any object to be in equilibrium. Equilibrium में रखने के लिए क्या होगा? Again, हमारे पास सिर्फ दो ही चीजें हैं. उन्हीं दो चीजों के साथ हमको प्ले करना है. क्या करना है?
So I remember this one. So the two conditions required for any object to be in equilibrium, one is related to the resultant force.
Okay,
When-
resultant force क्या होना चाहिए? Do you know what is resultant force?
So when you have forces, different forces acting on the same object, because it's a vector quantity, some forces may cancel each other out. So in the end, whatever force is acting and whatever direction it is acting in, that is the resultant force.
Okay, so if a quick छोटा सा example, suppose I have a box and इस box को एक तरफ से सरगुन push कर रही है और एक तरफ से गौरी push कर रही है. Gauri is applying 20 Newton force and Sargun is applying 20 Newton force. What will happen?
The box will not move.
The box will not move. Why? Because
The net force is zero. The resultant is
resultant
zero.
force is zero. Because it is, कई बच्चे इसको 20 plus 20 लिख देते हैं. Is it 20 plus 20?
No, it's 20 minus 20. They're in
Why
different
is it 20
directions.
minus 20? Why am I taking one? एक को minus क्यों लिया?
Because they're in different directions.
The directions are different. किसको minus ले लूं? Which one should I take minus? गौरी को या सरगुन को?
Sargun ko.
सरगुन
Because
को
of
भी ले-
the
अब I can take गौरी also, but हम क्या करते हैं? Usually हमारा graph होता है ना, graph के हिसाब से लेते हैं.
yeah.
Remember the graph? तो graph में left side is the negative side. So हम usually तो फिर हम सरगुन को negative ले लेंगे इसमें. ठीक है? Right? किसी एक को लेना है, सरगुन को ले लेते हैं. अभी क्या हुआ? अब गौरी ने बोला no, I want to be with my friend. I'll come here. अभी क्या होगा? Resultant force
40 newtons in the left direction.
क्यों होगा? अभी 20 plus 20 लूं, 20 minus 20 लूं.
20 plus
20 plus 20.
अच्छा, इधर क्यों ऐसा हुआ?
because they're doing it towards the same direction.
Absolutely. So 40 Newton. So resultant force is the word is clear to us, right?
Yeah.
So despite the moment exerted on the lifting arm, the crane remains in the equilibrium.
Equilibrium.
एक तो आपने बोला that you said that there is no resultant, मतलब zero resultant force, है ना?
Zero resultant force.
Zero resultant force.
Then I think another one will be the net torque will also be zero.
Net torque will zero.
Yeah.
Net torque is zero. Net torque is zero. Okay. Net torque zero कैसे करेंगे?
When the clockwise moment is equal to the anti-clockwise moment.
Absolutely. Very good. ये तो बहुत ही फेवरेट क्वेश्चन है बाबा. ये तोता गिरा हुआ. Something whatever.
I've tried solving this one.
Did you try? Okay.
Yeah, I've tried solving actually all the questions in the worksheet.
अच्छा, very nice. Very nice. In fact, abhi to you can start doing the rest of the motion ke bhi we have so many worksheets, right? So even if I am not telling you to do any homework, what you're supposed to do is do the next worksheet. Keep moving on.
Yeah.
Okay?
I've sent you some of the worksheets on email, this as well as the second worksheet.
This one also? Acha, I'll check.
But I'll just edit it a bit now because of what we've discussed. And I'll resend it.
Okay. Right. Sargun, chalo. Read karo. बहुत लंबी कहानी है इसमें. A question सिर्फ इतना ही पूछा. Calculate the mass of the counterweight. उसके पहले बहुत सारी story है.
Figure 2.1 shows a mobile board sculpture that has been created by an artist. M is the center of mass of the board sculpture, including its tail, but not including the counterweight that will be added later. The mass of the board and tail is 1.5 kg. The board sculpture is placed on a pivot. the artist adds the counterweight at the end E of the tail so that the board remains stationary at the position shown. Calculate the mass of the counterweight.
Mass of the counterweight. Okay, बताओ कैसे करें?
So yeah, this is again, there's a pivot, so we're going to look at the moment of force, except that here what I did was to save time. Instead of taking the weight into account, I just used the mass because on both sides it will be the same anyways.
Okay.
So what I did was that the mass of the bird with and the tail, like the whole sculpture together, is 1.5 kgs, and that entire thing is acting at that point 12 centimeters away from the pivot.
The
And
mass
now
of the tail, the bird and the tail is 1.5. Okay, ठीक है.
Yeah. And then at that other point, which is 30 centimeters away, there is another mass which is with the weight of which is acting, and it's countering that. So you need to basically make sure that the clockwise moment is equal to the anti-clockwise moment. So you
Okay.
calculate the
Can you
moment
annotate on my
here.
screen? तो यहाँ पर what I understood from your explanation that एक तो ये bird का mass इधर कुछ तो होगा. There is some mass here to the bird. तो मैं क्या लूँ? M ले लूँ या क्या ले लूँ? That should I take as M or what?
Yeah, that's fine. Yeah, M.
Yeah, or you have any other number here? Total is mass of bird and tail is 1.5. So either I take this as X and this one is 1.5 minus X, something like that, or what? How you have taken?
So what I've taken is, since it says in the explanation that M is the center of mass of the bird sculpture, including its tail, but not including the counterweight, I've treated the entire bird and tail as one, which is acting at that M, and the counterweight as what is going to be acting on E.
On E, acha, theek hai. So this is full is 1.5, and this we don't know, which
this is what we need to find out.
E लिख देते हैं, इसको E लिख देते हैं. Okay, all right. So this is a weight, so it is downwards. This is also weight, so that's why it's also downwards. This will move in which direction? This is clockwise.
Clockwise.
Yeah. And this will move in this direction, so it is
anti-clockwise.
Okay. Abhi kya? What next?
So
M पे calculate करते हैं. What is the moment of force at M?
Yeah. So that's 1.5 kgs multiplied by 10.
So force होना चाहिए तो multiplied by 10 करना पड़ा. Multiplied by?
Multiplied with the perpendicular distance. So 15 multiplied by 12.
Sargun, did you understand this part?
Yeah.
1.5 multiplied by 10 multiplied by 12. What is the moment of force at E? Now?
So the moment of force has to be equal to this, right? So the moment of force I'm getting at M is 180. So the one here has to be 180 divided by 30.
So E multiplied by 10 multiplied by 30 kar do aise. And then can I equate them? Then can I equate them?
Yes.
This will be equal to this one, right? So it's 1.5 into 10 into 12 is equal to E into 10 into 30, right?
Yeah.
So 10 and 10 both are getting cancelled, right? And we are left with only 1.5, 12 and upon 30 is equal to E, right?
Yeah.
Now, and we need to calculate E. ये निकल जाएगा. कितना आंसर आ रहा है इसका?
0.6.
0.6 kgs. Correct? ये बहुत favorite question है. I won't wonder if you also get a question like this in your test. Something, ये तो बहुत favorite question है teachers का. वो tail में ही बच्चे confuse जाते हैं. अभी क्या करें? That is why center of mass.
But it's saying that the mass is counted for the tail as well. So.
हाँ, but confusion create करता है ये थोड़ा question. Okay. If you've not practiced this before, चलो आगे करो. Center of mass is sculpture with counterweight. We will finish this question. Okay.
Yeah.
Next. Sargun, ये समझ आया बेटा आपको? पहला question. Very important question. Okay. And these questions, whatever we are doing, ये worksheets मुझे जरूर send करना after doing it. ठीक है? ये these worksheets, whatever we are doing, इसको अपने आप वापस एक बार हमने क्लास में डिस्कस कर लिया, but how much you are able to retain वो आपको अपने आप करके भेजना है मुझे. Okay, all right, चलो next.
So over here it's saying that the center of the mass and the counterweight is at the pivot. I'm guessing that that means it's acting on the pivot. So then it's saying calculate the upward force acting on the pivot. So we've done this kind of question before. Basically, the total of the forces that are acting like in this direction, in the downwards direction, has to be equal to the force acting in the upwards direction. So that's 1.5 plus 0.6.
So which is equal to, so एक तरफ 1.5 है, एक तरफ 0.6 है, 1.5 and 0.6. So the counter has to be upward forces
2.1. 21 newtons. 21 newtons.
2.1. Okay, so into 10.
Into 10.
To 10, both of them, right? So which is 15 plus 6, which is 21 newtons. This is 21 newtons. Next, Sargun.
The sculpture is rotated clockwise to the position shown in figure 2.2. It is held still, then carefully released. State whether the sculpture will stay in that position, rotate further clockwise, or rotate back anti-clockwise. It will rotate back anti-clockwise.
You have to give me a reason. Whatever you are answering, एक reason दे दो मुझे. Sculpture is rotated clockwise to the position shown in figure 2.2. Clockwise कर दिया rotate, okay? Clockwise is like this. So it was earlier in this way. So clockwise is ये ऐसे rotate किया. ये this is clockwise, right? This side. It is held still, then carefully released. State whether the sculpture will stay in that position, rotate further clockwise, or rotate back anti-clockwise. Give me a reason for whatever you're saying. Okay, so Gauri, Sargun has given her answer. What is your answer for this?
So first of all, even I had thought of the same answer, but then I thought that they were trying to trick us. So I think it will stay in the same position.
Okay.
And my reason for thinking that is because all that has really changed is the position. It's still in equilibrium because the counterweight is still going to balance out the weight from that side, and the perpendicular distance hasn't changed as well. Like everything is the same. So it's still going to be in equilibrium. So I thought that it will still stay in that position, especially since it's carefully released. It's not like pressed on. It's just released.
Right. So how do I write my answer? It will stay in the position because?
So I think the answer will have like the key points about it being in equilibrium, about the clockwise movement and the anti-clockwise movement being equal, and those points.
तो ऐसे करके छोड़ दिया और वो वैसा ही रह जाएगा because because the weights are in, the moment of force on both the sides are in equilibrium. So there has to be one side the moment of force has to be, which is not the case, right? So hence they will stay in the same position. Explain your answer that you've given. You understood what is the explanation?
Yeah.
Explanation is understood. So here it is staying in the same position. And here the answer would be, reason is because clockwise and anti-clockwise movement is same. Correct? Okay. So now that we have completed this one, I'll just go back to the sheet 1 second. All right. So if you see, today we are done with this one. Okay.
Yeah.
We still have these two. You can try these. Okay. Clear? These two you can try. Then even before motion, we had done only one. सिर्फ हमने ये किया है. अभी there are so many more. I think second आपने homework किया था, right?
हाँ, second homework किया था.
किया हुआ है, right? So you can try the third, fourth one. and you will ask me your doubts, whatever you're not. You know that you can get the answer keys for these. All of these are answer keys
Where?
here. So this is your question. This motion 2 is the word here. That is the answer key for the same.
Oh,
So you can
okay.
you will
Okay.
always cross check your answers. Yeah, and these answer keys come from IGCSE. So
Oh,
this
okay.
is very, very, your answers need to match with this. Any teacher who will check your test papers in school or even by Cambridge, they will always do it using these answer keys.
Understood.
Comes from Cambridge, all right? And
Got it.
even if I will check, I will match these two only. The keywords, the answers, the significant figures, everything needs to match.
Got
Okay.
it.
So it is mandatory when you're doing this, you will always check your answer with this, but do not copy. It will not help. है ना? So हम करने के बाद क्रॉस चेक करेंगे जरूर, क्रॉस चेक करना है. You have to be responsible enough कि क्रॉस चेक करके ये नहीं कि वो बस आंसर वहां से कॉपी कर ले. Then we are not learning anything. है ना? Then there's no point. Clear? So whenever you're doing any of these papers, you're always going to